Well, hello everyone. Rick Gurgitz here again with the Red Power Stores, and this is a continuation in our series of combine videos. Today's focus is going to be on our mid-range combines. Videos I've made in the past have been mostly focused on flagship, so it's time to get caught up again. Our base mid-range machine's been around for a long time. We're going to go over a lot of the settings and things that will help you have a successful harvest. A lot of information that we'll go through today is going to be repeated when we do our combine clinics, and this is just kind of a nice refresher. We'll post this video on our company's website, and then after the clinic you can go back and look at different segments of it. We'll kind of break it up. We'll go cover the feeder area, then we're going to do threshing, concave area, and then move back to sieves, and finally at the back a little bit on residue management. So we've got a 2577 and a 7150. So as we think back on this, a lot of this information will apply for everything clear back, if you go back to 1480s all the way up to 7150, 7160. So a lot of that base technology was set up in the late 70s and still continues on to this day. So we'll go over a lot of the different settings. So all right, we're looking into our rotor cage now. We've got everything coming up the feeder house as nice and smooth as we can. Crop mat's moving up, smooth through the transition cone. It's now entering our rotor cage, and here's where a lot of the magic starts to happen. So some things to think about first when we're in successful harvesting. Probably the first thing to think about as we look at this is a whole, and again, this hasn't changed since 1977 really, the theory of this. We've had some minor improvements, but the theory's still there. In our concave sections up to here, we have essentially, well, I should point out here, on this machine we have 6 of the mini concaves. They finally split them out. So we have 1, 2, 3, 4, 5, 6. We used to always just have 3 bigger, heavier ones, and they are heavier to handle. We'll not argue that point. Theory's the same, and then we have our separation grates in the back. So threshing up here, separation here. But we got to remember, in the whole theory and theme of things is, of course we have to have 100% of the thresh occur up here. In the old original thought process, it was also going to be 90% of the separation up here. So really, we get a lot of the work done here, and we're just doing finish up separation in these rear 3 grate sections. Well, I'm saying as agronomically as we have evolved, and we're starting to bump 300 bushel corn, 80, 90, 100 bushel beans, things are changing. The thought of getting 90% of the separation done up here, I think are out the door. I'm hoping for 75 to 80, just because of the sheer volume we're starting to feed into this. Because if you think back to when this was originally set up, 150 bushel corn was the norm in 77 and 40 bushel beans. So again, we've doubled up the corn yield and the bean yields. So assuming we're going to get 90% of the separation up here is not quite in line with the way I think anymore, but there are several things we can do in concave selection to help ourselves. So let's go through a few things first. This is pretty much a standard setup the way this is. This is what we call our large wire concaves, and then our key stalk grates. Been the norm for a long time. If we've got some older 2300 series machines, you gotta go back quite a ways, probably 21s. We've got the concave only come to about here, and then you had the add-on piece across here. But in the last 2 years, we've gone to the one-piece concaves, and they are a bear to handle. I'm not going to argue that point at all. But I see a lot of machines like this, and it troubles me a lot, because we're kind of forgetting what we learned years ago. Everybody used to remember pulling every other wire out of these to get more separation capacity. Well, for some reason, the last few years, we kind of forgot that and let it go by, and we end up with this setup like this. And I don't care for it. I think it will go out and harvest soybeans, great. But in corn, you're going to struggle to get much separation in here. We're going to thresh great, but you're too tight of a profile to get the grain out of here. I would almost assume in this setup, you're probably pushing it if you're getting 50, 60% of the separation complete up here, which means we're shoving it back in here, and we got to play catch up. And then we're fighting rotor loss because we didn't get our job done on this half. We're overloading what this half was intended to do. And then we can people start moving vanes around to play catch up and everything else. What we really need to do anymore is, again, either you got to pull every other wire out of these, which means take concave off, take the end plate off, drive the wires out. What I like more than anything as we're moving forward now is get some round bar concaves in here. I mean, we got to take a trick out of the flagship playbook and start using round bars. It'll help you immensely in separation, in corn. And on this particular setup where we have the half concaves, I'll call them, I would put round bars in here, here, and here for corn and soybeans. Because again, I am not going to set this up where you got to wrestle something out between crops. And that will help that tremendously. I did this on a machine last fall. It was night and day different on the amount of rotor loss we were fighting. The minute we put one round bar in here, happened to be on a 7088, made night and day difference. Our rotor loss just about disappeared instantly after that, and we were in dry corn. So it was, I thought it did a tremendous job. In the big picture, let's say we've got, like, the machine next right beside us is going to have the bigger, or I'll call it double piece concaves yet. So what I would recommend on that one is get a round bar in here and then pull every other wire here, here, and here. So then you're still opening up all this. Now again, we can pull every other wire and help ourselves, but the round bar does, I think, a lot more good than pulling every other wire will. If you happen to have a machine that you're doing soybeans only, not an issue. You can leave the large wires and go. But we definitely, in corn, again, if you start getting in higher moisture situations, higher yields, we got to start getting some round bars in here to help ourselves out. Once we get the round bar in here at least, and maybe pull these wires, or if you're going to be doing a lot of corn and higher moisture, you're going to want 2 round bars in. Just leave this for the thresh. You will still thresh off a round bar, but you'll get a lot more separation out of it. As far as in the big picture then, as far as vanes go, well, on this one, we're pretty well in the mid position. A few of these have slipped a little bit, but as we look at these, mid position is the best back here. And time again, I'll see, maybe we're in this scenario and oh my God, we're fighting rotor loss. The first thing everybody wants to do is slow these vanes down by sliding this where, straighten them up a little bit. And that is, to me, the worst thing to do, because yeah, it may help the issue that we created because we're not getting our separation done up here like we're supposed to, and we're trying to play catch up back here. If you're in that situation, if we're fighting rotor loss, go up here and slow these down. Here's where the problem is created because we're not getting the separation up here like we're supposed to. Slow these vanes down in the front section will do night and day more good than slowing these down. Because what we do back here, if we have these in mid, these in slow, we just created a traffic jam in this transition area anyway, because we've got our crop mat moving through here. All of a sudden we get up to here and we're trying to slam the brakes on it, and you create bunching and everything else in there. So again, these should be on the mid position probably, always probably not going to move them. If we have an issue that we can't seem to correct, we're going to slow these down up here. Leave it in this area a little bit longer as it comes in, give it another rotation perhaps, a little more separation, finish up thresh, whatever needs to happen. Then we're going to move it back to this final area and out the back of the machine. Another point, as we are looking at this, and again, this is going to vary a little bit with the age of the machine. You know, we've got in-cab concave adjust for a long time now. Some of them remember the old ratchet handle actually used to fit right up on this essentially, way back when. But right now this concave is up against the stop bolt, so it's at a theoretical 0 concave clearance. We don't really know if that's the case or not. It depends on how well this thing has been leveled and zeroed out. So what am I talking about with concave 0? Well, it's not the same as pinch point, but what it means is it's the number you're going to set the concave to. Does it compare the same to maybe your neighbor's machine? And I'm going to say typically no, because there's a lot of variability. First off, if we're going to adjust these, and figure out where 0 is at, really about got to drop a concave out or down. Put the rotor in neutral as everything's shut off, and you're going to spin it by hand, and you're going to close the concave up until the rotor bars, rasp bars start clicking on a concave. Then you know you're almost at the spark setting. You've got it, it's truly at 0. Well, we're not going to leave it there. We're going to bump it open a little bit, spin it again till we don't have any contact anywhere. Then we're going to run these stop bolts down like they are here, tight, snug them up. Then we can go up and do a concave calibration. So we can tell, that's telling the machine, all right, this is a 0 setting. And then as we start opening it, then it's going to tell us, okay, we're at this setting, you know, if we go to 20 mil, 25, whatever. So it's a little bit more difficult on these. The flagship's pretty similar though, I guess. To give out concave settings are a bit of a generalization because we don't know how well this was zeroed at day 1. Because I have come across some of these where these stop bolts are set and there's a full 1/4 to 3/8 of an inch between the rasp bar and the concave. So it's going to make a huge difference on that as to where we start initial settings for a machine. So let's take a look at a round bar concave. And it is just what it sounds like. Instead of the wire and bar layout, it's just a set of round bars welded in there. Nothing magical about it. Really mimics what we do use in the flagships anymore. Same type of thing. There are some different variations of this floating around. We had one of these earlier versions that actually had wires underneath the backside coming through. That's a much older version, and that didn't work well. You had to get rid of those wires to make that one work correctly. What we want, wide open profile, in order for that material to get flown out, get through there, and get it down onto our auger bed. So just a quick view of what a round bar is. Now this is a double wide one. They do make this in the split version that would only be this wide, similar to what we just looked at in that machine. But you can mix and match. You can put double wides in there if you take 2 of those out, whatever you need to do. So just a quick view of what a round bar looks like. So we're over on the 2577 machine. Again, identical layout. A little difference with our indicator, still one poking through the side door. Still have the motor up here. The vanes, everything in here are identical. Where our vanes, you know, how we set them. 3 separator grades, key stalks. And again, up here, we got all large wires in with a full complement of the wires yet, which I would really recommend tweaking different. But again, here we have the solid, or I should say the 2-piece, old original style kind of a concave. So if we are going to change concaves out, we have to remove these bolts up here. There's usually 5 per segment. And then we got to do a little work on the opposite side in order to drop these down. The other thing to remember when we're doing these is typically, if we do want to switch this one out, typically you're better off to drop this one down and scoot it forward out of the way. Then drop this one down, move it forward. This one is, you can't hardly get it out of here in this vicinity. It has to get moved forward a little ways to get this one in and out. Not a fun in-season job because this is all going to be packed full of dust, and the minute you open the door you get a face full of that and whatnot. But again, pre-season, not such a horrible thing. It is a 2-person job. One thing too, stop bolts, same thing we were just talking about, but they are different on this vintage machine. Not quite as heavy. Same theory though. We're still going to zero the concave the same way, closing it up and all that. So continuing on changing the concave, we're on the right side of the machine now. You got to remember we got our clamp pipe up here that we have to loosen up in order to get the tail or the back leg of the concave off that. So we got to loosen up all these jam nuts on the eye bolts. Once this is loose enough, this pipe will flip over down in this area, take the tension off of these. Then once we've removed those bolts on the other side, the concave should drop down, and then we can maneuver them in and out. Now, I will tell you firsthand, these are not fun to work with, but what I have found that works the best when we're switching these out is get 2 people. 2 of you get it fed in here. The second guy comes over here with a pry bar, and as that concave is scooting across in here, get your pry bar on it and start lifting to get it hooked up on top of here and here. Once you got it hooked up on here, which is a job, they're heavy, Then you can scoot it around, get your bolt started on the other side again. So just a little tip on those. But again, in season, this is going to be packed full of material, not near as fun a job as it would be on a day like today. So as we've got our concave selection under control now, we've got our vanes where we want them. The only really other thing we got to talk about yet is threshing elements, of course. We've got our regular rasp bars up here, pretty much the standard. The one point I really want to hammer on back in this separation area is straight bars, which I have right here in my hand. Straight bar is either going to, it takes a place of 2 rasp bars. Historically, these machines, ever since we came, I guess way back to the specialty rotor, way back, we added straight bars back here. What's their purpose? What are we doing with them? Well, what they're meant to do is when our crop mat gets into this area, rather than just rifling it out the back, we do want to finish their separation up in here. So these disrupt or tear the crop mat apart a little bit, which makes it then reform again. Well, in the process of ripping it apart and reforming, if there's any kernels caught in there, they will fall out, and the centrifugal force will then help spin them out of here. The issue that we've got is a lot of these used to come with 8 straight bars in this area. And it still does, even this one appears to have 8 in it too on this newer machine. It depends on how they were ordered, all sorts of things. Straight bars are great. In corn, they all day long, they won't hurt you. In beans, they are probably your biggest enemy of productivity in 2 different ways. And that's why we can't just take or leave straight bars in. We kind of got to find a happy medium. I like 4 straight bars in these machines. If we have 8 in them, great deal for corn. In beans, they work against you in 2 ways. If you have green straw early season, they grind and growl and suck horsepower tremendously by putting 8 of those in there. The other way they are not your friend in soybeans is if we get dead dry conditions, you got 8-9% beans, the straw is powder, they continue to thresh and tear that crop mat up so bad, everything, the straw ends up down here on our sieve bed. So we over separate, I guess, because it's not really threshing, but we over separate, tear it up too much, and we just dump it down in here, and then we're fighting sieve adjustment issues because we have flooded them with too much dry material that should have went out the back in the chopper, out that way. So to me, 4 straight bars is the answer because we need them for corn, but you only want 4 in there. And that's the one thing you take away from this video is check your machine with the rotor neutral, start spinning, and start counting your straight bars. They're going to be back in this area. And again, you can see there's one right there. I got another one right down here. That's why I'm pretty sure there's 8 in this one. And we want to get it balanced. If we're going to remove them, you got to make sure you keep everything in balance in that regard. But it will help you immensely in tough soybean straw horsepower and then dead dry. If you got a machine that you're doing corn only with, then 8's fine. Not going to hurt a thing. If you're doing super high moisture corn for cattle feed or something, 8's a good idea. 12 row heads, things like that. If we're really pushing the capacity of this in corn only, 8's not going to hurt you. But again, if we go back up here and get our round bars in, some things like that, we take the load off this area in general. So that helps a lot. So again, pay attention to how many straight bars you got, and you may need to remove some. So we've kind of went through a lot of our threshing stuff up here. The other thing to remember through all of this, especially in corn, the number one problem I run into is people trying to run these rotors too slow. In my book, I still think you need a minimum of 380 RPM in corn. I get out there, I see guys trying to lollygag around 325 and that. That's 1460 days. Those are long gone. A lot of times I'll start any of these at about 410 for a rotor RPM and going out into corn and see what it does. We need the centrifugal force to get the separation to occur, not only up here, but back here too. The slower you go, the less spin you got, the less it wants to move the grain to the outside of the cage, the more apt you are to auger it out the back. So again, higher rotor RPM in corn. 400 is my go-to number, 410, somewhere in there. even in 15% corn, I rarely ever get below 380. At that point, we're just going to feed it a little faster, get a little more in there, get a little more through it. Because that's the other thing too to remember, on rotor RPM, we got our crop mat started nice up in the feeder house. We're bringing it in the machine. Don't pinch the concave down and slow the rotor down, because you just created this huge log jam and we can't get anything through the machine. So we're going to fluctuate. We're going to keep this rotor RPM in corn, we'll say at 400. We're going to bump our concave open and closed until we get the cobs where we want them. And as always on these machines, you let the cobs coming out the back of the machine tell you what you need to do. We're looking for hopefully 75% almost whole cobs. And if we're not getting that, and we got kernels on whatnot, we got to go back up here and do some tweaking. And that's a little bit more field-to-field conditions, hybrid and things like that. But those are the key things to remember. The cobs coming out the back tell you what you need to do up here. And again, that RPM helps you. Soybeans, same scenario. We still need pretty good RPM in soybeans, but there's a lot of variability in them depending on how tough the straw is. A lot of times we're going to be 650 to 700, you know, especially if we're pushing 35, 40 foot head through these. Keep that spin on it, and then tweak our setting here a little bit to determine what we need to do to get the thresh and the separation complete. So now that we've kind of moved through this area, we've got everything threshed, separated out, and we dumped it down onto our auger bed. And here's where the big change comes between the flagships and these. This is the auger bed from the original design. It just grabs all the material, moves it rearward, starts putting it on our sieve system. Flagships have an active grain pan in them, so that's a little different the way it is presented to the sieves. This pretty well concludes what I wanted to go over on mid-range combine, just for some general setting things and that. Again, this is just a reference thing. It'll be a video posted on our redpowerteam.com website. I'll go over a lot of these same points in our in-house combine clinics we have coming up. But I want to have this stuff posted. That way, if we go, as you go through the clinic, if there's some point you want to go over again, you can just go back and reference it on one of the videos. You can even pull it up on your phone when you're out in the field if you want to look at something again. So again, thanks much for watching.